A solar site assessment generally begins with the homeowner, making their own evaluation about whether their home has good exposure to the sun. The orientation of their roof and the obstacles that shade it are potential issues in the ability of their solar electric system to generate the maximum amount of electricity. Next, the homeowner would contact a solar professional for a site evaluation and installation estimate. Most companies will look on Google Maps to pre-assess the suitability of the location. They'll look at the orientation of the roof relative to true south, the available roof surface, and any trees or obstacles that may shade the roof and decrease its direct exposure to the sun. The on-site assessment begins with an interview of the homeowner to gauge their motivation and preferences. Very often the homeowner has an idea for where they would like the system to be installed. The assessment continues with a survey of the site to locate the shading obstacles that were identified in the pre-assessment. Once the technician and the homeowner have a sense of where the installation might go, they move to the next step, measuring the location's solar resource. This is a measurement of how much unobstructed sky can be seen from that location. The result of this measurement is called the total solar resource fraction and is given as a percentage.
For example, if a perfectly tilted array facing true south were placed at a given location, a total solar resource fraction of 88% means that because of obstacles shading the collectors during various times throughout the year, that system would miss out on 12% of the potential solar resource. Many financial incentive programs in Oregon require a minimum average solar resource fraction of 75%.
Solar resource fractions can be measured using both high and low-tech instruments. An example of a high-tech instrument is the SunEye Shading Analysis tool by Solmetric. In addition to a personal digital assistant, the SunEye includes a compass, a level, and an onboard digital camera mounted with a fisheye lens. The SunEye captures an image of the surrounding shading obstructions using the digital camera, then analyzes the shading relative to the expected path of the sun throughout the entire year. The result of this analysis is the location's solar resource percentage. The Solar Pathfinder is a much simpler solar resource tool that uses a compass, a leveling bubble, and interchangeable paper sunpath charts under a transparent but reflective domed lens. The sunpath charts show the daily path of the sun for each month of the year. The dome reflects the image of all surrounding solar obstructions, allowing the technician to take a photo that captures both the sun chart and the obstructions in one image. With the photo in hand, the technician identifies the areas of the chart that will be shaded and hand calculates the solar resource fraction. Next, the technician will measure the available roof area in order to calculate the number of panels that can fit on the roof, and will identify any roof penetrations like vents and chimneys. Some penetrations like sewage vents can be moved to open up a greater area for the panels to go down.
Another consideration is the age of the roofing surface. Some incentive providers require 10 to 15 years of remaining life expectancy for your roof material. Moving from the roof, the technician checks the attic for access and assesses the capacity of the structural members to support the dead weight of the solar panels, which can weigh between 3 to 4 pounds per square foot.
The load is generally not a problem for roofs which meet current building codes, though older homes sometimes require an engineering analysis. Next, the technician needs to inspect the electrical services. They'll identify the make of the electrical panel, whether it's been installed to today's code, and if there is room on the panel for new electrical breakers. They also need to identify wall space to locate the inverter, the disconnect, and the new production meter. Lastly, the technician will ask the homeowner for a copy of a utility bill in order to gauge the homeowner's usage and estimate the potential offset of the new system. Soon after the inspection, the technician will present the homeowner with an estimate on the size and cost of the system, and will also discuss the financial incentives available to help cover its cost. With the site assessment and estimate in hand, the homeowner is now ready to decide how to proceed with their new solar electric system.